Can everybody read this stuff? So I have a simple Firefox exploit. Here's an HTML file. Basically, we need to create a 2200 byte buffer of A's and then put WMV at the end. And if we create an embed tag and launch Firefox, once Firefox renders this embed tag, it will blow up and we will cause Firefox to crash. We will get control of EIP and all that fun stuff. So let me run this and let's see Firefox crashing and burning. Okay, so here's Firefox. I've started that web server. Let's load it up. Just pointed at the web. Just pointed at the web server, and there it goes. Firefox crashes. Okay, let's do it again, and this time we will attach a debugger to it and see what happens. So here's the debugger. Attach this to Firefox. Don't worry about this debug shit. I'll walk you through it. Okay. So there we are. Launch it again. Wait, I need to run that web server again. Okay, there it goes. Crashed. Now let's look at the debugger. And debugger is waiting at an exception. If we proceed further, basically we get control of the instruction pointer. We get EIP equals 41414141. For those of you who took the exploit lab yesterday, you know what this means. Basically, we can put the shell code and win. So let's do that. Let's actually convert this into a practical exploit and make it work with shell code. The problem here is, where do you want to jump after you get EIP control? You can't jump back into the stack, you can't jump to registers, you can't jump into DLL. But what we're going to do is we're going to populate the heap memory, load up our NOP sleds and shellcode in the heap, and then jump into the heap and win. So I'll show you an example of such a heap spray. Let me run Firefox again. And let's see how we can convert this crash into a real working exploit. So here's a final exploit that is pieced together. It's the same thing. I mean, what we're doing is we're still doing the same trigger, 2200 A's and triggering it, except we are now jumping to an address which is in the heap, address 05050505. It's an address picked at random, but at this address, you will find a very large NOP sled, which is created by this JavaScript loop. And then the NOP sled and shellcode are sprayed 50 times over the heap. And that's easy enough. And this will break, this will cause our shellcode to run. And here's the shellcode, also included with the HTML, nicely written in JavaScript. And the shellcode runs calculator. It is, the next hello world of all shellcode. That's calculator. So let's run this and see Firefox turn into calculator. Okay, there it's running, and now let me hit this. First attach that debugger. There we go. Run it. Here we are getting an exception. If we look at the next step where we're going to jump to, the next address we're going to jump to is at 05050505. For those of you who are technically inclined, if we look at the memory occupied at 05050505 right now, you have these NOPs, all these NOP codes, and if I proceed, at the end of this NOP sled you have the shell code. This is return to heap. So if I now proceed further, you get a calculator. So voila, your Firefox stands exploited. We get a calc running, and I mean, instead of a calc, you can do anything. You can now have a Trojan downloaded and make this a part of a big botnet and whatnot. So Firefox is owned, and this is how browser exploits work. How do you stop these things? How do you prevent browser exploits? I have not found a satisfactory answer yet. If you think of antivirus stuff today is only good for slowing down your computer and playing old DOS games. Does nothing else. Get a faster computer, it still feel like a 386. It's nostalgic. Why is antivirus so pathetic and ineffective when it comes to stopping browser overflows or browser attacks? These attacks are not like your traditional classic exploit attacks where the payload has to go in with a very large buffer and the shell code and everything goes together. I have JavaScript and I can build up an exploit entirely with JavaScript. I can obfuscate this, I can encrypt this, I can build this exploit up in parts. I mean, simple things that I've done have also fooled some antivirus programs. Let me show you. For example, if I just take this exploit and I revise it a little bit. Here's the same exploit, but instead of creating an embed tag in one line, I can create an embed tag using just 5 cuts of a string. I can piece together an embed tag with something like this: document.write s1 plus s2 plus s3 plus buffer plus s4 plus s5. I mean, simple stuff like this will fool antivirus programs. There is no signature that you can apply. And I'll show you some code pulled off from Chinese malware sites, which is unique every time you load the code. Every time you load the code, there's new JavaScript being generated on the fly, and there are actually encryption keys being sent through cookies. So JavaScript gets loaded, key comes in through a cookie, it gets decrypted, and then it blows up. So there is no way you can signature these things, and therefore there is no way these attacks can be effectively stopped unless you build in some granular security inside the browser. So that's the point which I'm trying to make. So the problem is, exploits can be delivered by JavaScript. They're built up on the fly. They're actually delivered locally because JavaScript gets loaded on your machine and then exploits your browser. It's not a remote exploit at this point. It's just remotely loaded and locally exploited. And you cannot signature this. So nothing really, you don't know if you have an exploit at hand unless everything fits together at the last moment. So you have to be in the browser to be able to stop these type of exploits. So I already ranted about the effectiveness of antivirus software, and I'm not going to slam on antivirus anymore. I guess because part of the antivirus guys sponsor this conference. I can't really piss on him too much. But what I'm going to talk to you about is my attempt of protecting against browser overflows. Ideally, the code that I've written should be built into the browser kernel itself. Right now, I've just implemented it as a plugin, but I wish there is some standard coming up and this code gets built inside a browser. So, what are the objectives of Teflon? What I like to do is, sitting inside the browser, I can inspect the DOM every time it changes. I can inspect DOM mutation, and every time the DOM gets changes, I can take a look at it before it is being rendered. Slightly slow, but not that terribly slow. If I see an offensive vector, if I see like a malicious object tag or an embed tag based on some signatures that I know, or something like, this object tag is taking up like a 20,000 byte parameter, I don't want that to happen, I can rewrite the object tag before it gets rendered, or I can kill it, or I can replace it. And thereby, I can block these type of browser attacks from being rendered. So all I need to do is prevent malicious browser system calls. I'm not going to disable JavaScript. I would like rest of JavaScript to run. but just parts that create these malicious tags, I want to stop them. Current iteration of Teflon is 0.2. I'm soon going to open source this as soon as I get back home to India and take a week's worth of rest, which I haven't had in a long time. And currently it exists for Firefox 1.5 and 2.0. I'm working on Firefox 3. If anybody of you has any experience in coding Firefox 3 extensions, I would welcome your help because the Firefox 3 documentation is pathetic. It sucks. So all you have to do is reverse engineer other extensions and build it yourself. So it doesn't matter how cute that orange fox looks, so the documentation is broken. And eventually I want to have a plugin written for Internet Explorer as well. Right now what I'm doing is simply replacing these malicious object tags with a big red div tag. So there's a big red bar on your browser which shows you something bad would have happened if Teflon wasn't there. The rest of the stuff will run. And you may recursively obfuscate it anytime, any amount of times you like. You can create nested loop of 5-6 iterations, and the 7th iteration may cause the exploit to come together. It doesn't matter. I mean, with Teflon you can block these things. So let's see the same exploit in Teflon, and then we'll see how it works with packed and obfuscated JavaScript and other stuff. Right. So, coming back here. Let's take the same exploit and let's let me run that web server again with the basic exploit, and this time we will turn on Teflon and see how that works. So there goes Firefox. Okay. And here if you look at the bottom corner of Firefox, you have a little Teflon thing. I'm very poor at user interfaces, so even this type of a Zoom interface took me a day to write. I'm a command line guy, I don't like these GUI things. So what I'm going to do is you click it, Teflon turns on, and now it's actually it's actually a Firefox plugin. There's Teflon. Another thing I want to do is also start up the JavaScript error console. So Teflon writes to the JavaScript error console. So we'll track these events and see what Teflon says. Okay, now let's point it. Same Firefox exploit, Teflon turned on. Okay, we don't get a cal. It says it just replaces it with a big red bar. And let's look at the JavaScript console. Over here, try and see if I can increase the font size. Yeah. Let's see if I can. Can't increase the font size. But over here it just says that whenever Teflon encountered that big object tag, it replaced it with a it just replaced it with a div style is equal to border thick solid red. And this is just my mark to show that something was replaced. It could just be silent about it and log into a file or whatever have you. Let's do a view formatted source. And let me show you what the rendered source looks like. Okay. So here's the rendered source. Div source is equal to all this. So everything else remains the same. The object tag just got transformed into a div tag and with a solid red border. Okay. Now let's take some more complex cases. I mean, this is all well and good. Here's a simple exploit. There are many JavaScript obfuscators. I mean, I tried a couple of them. There's one called /packer. It's available on a site called dean.html.